Hello everybody, so today we will be learning chapter 8, which is on wave properties of particle. So this is a very short chapter. There are only two subtopics, and the first one is on de Broglie wavelength. Okay, so what do we need to know in this subtopic is basically we need to state what is wave particle duality and use the equation for de Broglie wavelength. Right, so wave particle duality, it states that at certain time a particle could exhibit wave properties and at other times it can exhibit particle properties, okay? But we cannot observe both behavior simultaneously lah. Okay, so the properties that are mutually exclusive is for particle, it has both mass and momentum. Okay, so it has both mass and momentum when it is in motion lah. Momentum ni when it is in motion. So untuk waves pula, the properties are it has wavelength and interference and diffraction of waves can occur. Okay, so itu adalah the properties of waves. So if we look at the particles and waves being reflected by a mirror, we can see that the particles would also be reflected in a way that it is still gonna be exactly the same as the as the original wave lah. Okay, particles. Sama juga untuk wave, dia sama. And then untuk diffraction of particles and waves, dia pun akan sama in a way that when it passes through a barrier, it will basically just go on and produce a straight shadows lah. Tapi untuk wave pula, dia akan bend into the shadow, as in dia akan expand ataupun dia akan try to accommodate the edges here. Macam tu lah. Okay. Right, so that is that. And then let's look at the Broglie relation. Okay, the de Broglie relation. Okay, so from the Planck's quantum theory, we know that energy of a photon is E equal to hf. So the frequency here can be calculated by using the speed of light by dividing the speed of light to the wavelength. Okay, so after that we can then equate these two together, and we have an equation that looks like this. So h here is the Planck constant. The value is 6.63 times 10 to the power of negative 34 joule second, and then c is just the speed of light in vacuum lah. Okay, so by Einstein's theory of special relativity, the energy equivalent of a mass is E equal to mc square. Okay, so when we substitute hc over lambda here, we get an equation that looks like this. So mc is equal to h lambda. So what is mc here? This is actually telling us the momentum. So momentum is mass times the speed, mv, which is the velocity, and c here is basically the speed, so it is actually v lah. So the momentum of a photon of wavelength lambda can be calculated by using this equation here. Okay, so this is just basically mv equal to h over lambda. Macam tu lah. Right, so the particle aspect of this photon is the momentum, and then the wave aspect is the wavelength lah, right? So the light wave has both momentum and can exhibit particle properties lah. So this is telling us that light can behave like waves and in other situations like particles, okay, such as photons lah. So these two here are the evidence that show that the wave particle the evidence to show wave particle duality of light lah. So we've learned about Young's double slit experiment in chapter 7. So this is just to tell us that it exhibits wave properties, and then the photoelectric effect to show that it exhibits particle properties. Okay, so Louis de Broglie suggested that matter ataupun electron and proton might also have a dual nature. So he proposed that any particle of momentum should have a wavelength lambda. So what is this lambda? This lambda is known as the de Broglie wavelength. Okay, so it is given by this equation here. So this is the equation that you will be using for this chapter. Okay, so the wavelength here again represents the property of wave, and the momentum represents the property of particle. Right, okay. Now, let's look at subtopic number 2. We have electron diffraction. Okay, so in this subtopic, you have to be able to describe the observations of electron diffraction in Davison-Germer experiment. Next, explain the wave behavior of electron in an electron microscope and relate that to the de Broglie wavelength of electron with the resolving power of the microscope. And lastly, state the advantages of electron microscope compared to optical microscope. Okay, so this is a diagram to show the electron diffraction tube. So basically what's happening is a beam of accelerated electrons strikes on a layer of graphite. So it is extremely thin, and diffraction pattern, which is the wing shape, can be seen on the tube screen. So this is telling us that the de Broglie relation was actually right. So the wavelength of this electron is can be calculated using this equation here. And then electron also appears to act as a wave whose wavelength is inversely proportional to their velocity. So basically, lambda is inversely proportional to their velocity. If the velocity of electrons is increased, the rings are seen to become narrower. So basically, the wavelength reduces in size, showing that the wavelength of electron decreases. So how do they control the velocity of electron? They vary the applied voltage. Okay, so for this situation, the electrical potential energy will be equal to the kinetic energy. Hence, we get an equation that is like that, and then we know that lambda is also equal to h over p. So when we substitute the expression of momentum here, we get an expression like this. So this is an equation that you can also use when the question only give you the voltage. Okay, so the wavelength of electron decreases with increasing voltage. Okay, so what you need to know, all particles will behave like waves, not only electrons. The diffraction effects are less noticeable for massive particles because of their momentum that is much higher, so the wavelength is shorter. Diffraction of the particles are observed when the wavelength of the same order as the spacing between plane of the atom. Okay, so that's just some of the notes that you need to know. Right, so let's look at example 1. I believe this example 1 should actually be here. But that's not the problem. Let's just look at the electron microscope first. So electron microscope is a device that relies on the wave properties of electron, okay? And then the diagram is basically showing you the electron microscope punya how do I say, device lah, dia punya gambar. Yalah, the device, okay? So the transmission electron microscope TEM, it is a beam of electron that passes through an ultra thin specimen to form an image, okay? So the image is then magnified and focused onto an imaging device. Then the TEM image contrasts due to the absorption of electrons in the material due to the thickness and composition of the material. That is TEM. Now we have scanning electron microscope. So basically, beam travel through the electromagnetic fields and lenses then focus the beam down toward the sample. The beam hits the sample, and then electrons and X-rays are ejected. And then the detectors collects X-rays and electrons and convert it into signal, which then the final image will be projected onto the screen. So this image here is basically it's actually an image that I got from using scanning electron microscope when I was at the UK. So this is my how do I say it? This is my dissertation now. This is my final year project. So what you can see is basically the structure of the bone cement. So my project was on bone cement last time. So this is the scanning electron microscope I use it to tell me how is the structure, how do the structure look when you zoom in using the microscope. As you can see, these are two different materials, two different types of bone cement punya properties. Materials yang I used lah. Okay, so kalau kamu tengok betul-betul, actually kamu boleh nampak clearly lah bila kita guna scanning electron microscope. Okay, right. Okay, so next we have the wave behavior of electron in an electron microscope. So electron is accelerated through a high potential difference, so they have very high speed. Again, the potential energy will still be equal to kinetic energy, so we have this equation here. So as velocity is very high, electron gain very short wavelength of order 10 to the power of negative 10 meters. So velocity high, wavelength shorter lah, resulting in a much higher resolving power. Okay, so this is the comparison between the electron microscope and the compound microscope. Okay, so both are able to see small objects with some differences. Electron microscope uses wave properties of electron, whereas compound use visible light. The wavelength of electron should be approximately or less than 10 to the power of negative 9 meter. So they can distinguish clearly 2 points separated by a distance of nanometer lah. And then the wavelength of the visible light should be less ataupun equal, approximately atau equal to, approximately atau less than 10 to the power of negative 7 meters, so they can only distinguish it clearly in a distance of micrometer. Okay, so these are the advantages. So if we use electron microscope, it has a very high resolving power due to the short wavelength of electron, and then untuk compound, the visible light need to have a certain range, so it should have been below 0.25 micrometer to 0.3 micrometer. Next, the resolving power can be adjusted with the voltage applied between the cathode and anode, but then for a compound microscope, resolving power also can be changed ataupun adjusted by changing the lens magnification. Right, so if you can see, electron microscope, of course, is a little bit more advanced in comparison to the compound microscope lah. Example 1, we have to compare the de Broglie wavelength of an electron and a proton if they have the same kinetic energy. So they gave us everything. So they say that the kinetic energy of electron is equal to the kinetic energy of proton. So basically they will have the same kinetic energy. So I'm just going to label it as K. So if we are going to use the de Broglie wavelength formula, this is basically just lambda equal to square root 2 MeV. This is H. Okay, so from this equation here, we can actually let EV here to be equal to K, because kinetic energy is equal to the potential energy, which is equal to EV. So substitute dalam ni. So this is MK square root H. Now we are gonna let lambda electron to be equal to H 2 MEK. They are the same. And then do another one for the proton. So this is 2 MPK H. Okay, so they do a ratio between these two because they ask about comparison. So I'm just gonna do the ratio between electron, the wavelength of electron and proton. So that is H over 2 MEK H over square root 2 MPK. Right? So we can cancel the one that is same, which is H 2K 2K. Okay, so we are left with delta E delta P equal to square root besar. So since this one is H over this thing, then over dia naik atas, so dia akan jadi mass of proton over mass of electron. Okay, so from here, it will be equal to 1.67 times 10 negative 27 divided by the electron, so 9.11 times 10 negative 31. So you will get the ratio between the wavelength of electron and proton to be equal to 42.8. Okay, that is the solution for example 1. Example 2, we have an electron is accelerated from rest through a potential difference of 2000 volts. Determine its de Broglie wavelength. So since dia bagi kita voltage sahaja, we are gonna use 2 MeV. So this is 9.11. Sorry. Betul lah. Negative 1. This is 1.6. Negative 19. This is 2000. And then this is 6.63, 10 negative 34. So it will be equal to 2.75 times 10 negative 11 meter. All right, so that is question A. Question B, we have an electron and an electron and a photon have the same wavelength of 0.21 nanometer. Calculate the momentum. Calculate the momentum and energy of the electron and the photon. Okay, so for the momentum, it is just P equal to H over lambda of the electron. This is for electron, so 6.63 times 10 negative 34 divided by 0.21 negative 9. So momentum is equal to 3.16 times 10 negative 24 kilogram meter per second. And then the energy is just K equal to half mv square. And we know that momentum is equal to, let me just think. Momentum is equal to mv. Right. Okay, why am I confused? So if we substitute for v, okay, so if we let v to be equal to P over M, we can substitute into this equation. So K is half M P over M square. Kan? Okay, so we get K M P square over M square. Sebab ada square. Alright, so we cancel. Satu, ini cancel. So K is equal to P square over M. So kinetic energy is, P is berapa tadi? 3.16 negative 24 divide by 9.11. Mana hilang 2 saya? 2 negative 31. You will then get 50 pula. 5.48 times 10 negative 18 joule. So if you want to convert it into electron volt, you are gonna divide it with 1.6. Divide this with 1.6 times 10 negative 19. So you will get 34.3 electron volt. Okay, so that is the answer. I think I didn't give you the sign conversion for chapter 8. Basically, this sign conversion here is on chapter 9 ba to? Ada di situ. Tapi tiap pala, hindi kamu akan belajar chapter 9 juga. Okay, lepas tu untuk photon. Okay, didn't expect for this question to be that long. Okay, for photon pula, momentum dia is the same sebab this is H over lambda. Lambda dorang sama, so they are gonna be the same. So this is the momentum, The energy, however, for a photon kamu akan guna Hc over lambda. Okay, tadi kamu guna kinetic energy untuk electron, tapi untuk photon kita akan guna Hc over lambda lah. Right, so this is 6.63 negative 34, and then this is speed of light divided by the wavelength. So you will get the energy to be equal to 9.47 times 10 negative 16 divided by the electron punya charge to get the value of to get the answer dalam electron volt. Okay, so that is the energy untuk photon. Okay, tapi let me just check. Kejap, let me just double check. This is Yeah. Okay, so untuk elektron dengan photon, energy punya formula is different, okay? Energy untuk elektron kamu akan guna half mv square. Tapi untuk photon, you are gonna use hc over lambda. Okay, so that's it for chapter 8.